So once again, welcome to a new problem. This time we have a table edge that's extending a distance of 2.2 meters. So this is a table, and it stretches from the left edge up until the right edge, a distance of 2.20 meters. And then also it's supported by two legs, 1.2 meters apart. The distance between the left leg and the right one happens to be 1.2 meters. So that just means that the weight of the table, which is acting right in the middle, is mg. I'm just going to call it, like mtg. I'm going to call it mtg, mass of table times g. The distance between the center of gravity of the table up until the right leg would be half of 1.2, which is 0.6 meters. And then also another piece of information that's given is the fact that from the right leg up until the edge of the table, we have a distance of 0.50 meters. The question, so this is the information that's given. The question for this problem is, if we have a person standing right here at this side of the table, we don't know what the distance is from the right leg of the table. We're going to call that D. That's their distance. Oh, let's just call it X, the distance from the right leg of the table. And we want to find out, let's call that X1, and then the distance, their distance from the edge of the table, let's call that X2. So we know that X1 plus X2 is equivalent to 0.50 meters. But we don't know what X1 is. We can always find that. The system is in equilibrium, so we can get the torque, the sum of forces and the sum of torques around the right leg or right support. So from this point, the sum of torques will be 0. We're also given some other piece of information that was given was the fact that the weight or the mass of the table, mt, equals to 60 or 24 kilograms. That's a piece of information that's given. And another piece of information is that the mass of the person, we need to write this out, the mass of the table, mt, so mt mt equals to 24 kilograms, and then the mass of the person, mp, equals to 66 kilograms. That's the information that's given. Sum of the torques around this point is 0. The person has their weight pointing downwards, and that's mpg, just like the weight of the table is pointing downwards. That's mtg. And so if the sum of torques around the right support is 0, then we can go ahead and say that the table will have a counterclockwise moment around the right support, and so that's going to be positive, and then the person will have a clockwise moment around the right support. That's going to be negative. So we have positive mtg times the perpendicular distance, which is 0.6 meters, minus, because the negative torque is clockwise, mpg, that's the force, times the perpendicular distance. We don't know what it is, so we call it x1. That's going to be 0. Our goal is to solve for x1. So we see that we can divide both sides by g. That way we can cancel the acceleration due to gravity. And so mp x1 equals to mt 0.6 meters. Divide both sides by the mass of the person. And so x1, if you plug in the numbers, you get 24 kilograms of the table, 24 kilograms. Mass of person, 66 kilograms. And then the mass of the table, the distance, this perpendicular distance from the center up until the edge, that's 0.6 meters. So x1 becomes equivalent to 0.218 meters. And remember, x1 and x2 are equal to 0.5. So we'll go to the next page and say if x1 plus x2 equals to 0.5, I don't know why I'm saying 0.05, but this is 0.50 meters. So x2 has to be 0.50 meters minus x1, which is 0.50 meters minus 0.218 meters. And so x2, which is the distance we were looking for, just want to clarify, this is 218, yes. x2, the distance we're looking for, becomes 0.282 meters. And that's the distance that the person has to stand on from the edge of the table. So this distance right here. Again, we use torque, assuming that the sum of torques around the right support is 0 because the system is in equilibrium. And so we simplified that using algebra, and we're able to get the distance x1, which is the right support to the person itself. And then these two distances, x1 and x2, are equivalent to 0.50 meters. And so when we subtract 0.50 meters for x1 from 0.50 meters, we get 0.282. So hope you enjoy the problem. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks. Bye.